So for those of you that don't know our family, there's 5 boys and 2 girls in our family. My brothers Galen and Glenn do the farming, and so Galen operates our farm here. And so a lot of the things that we've done over the years, Galen has helped me with that, and we've learned a lot together. So he's got a few things that he's seen this year that he's going to share with us.
Okay, well, I'm not going to take too long. Just going to show a couple things. On our farm, we've been working on the last few years. Number 1 is plant emergence. 2 is boron. How do we get boron in the plant? And 3 is phosphorus. We try and document everything we do so we can learn and improve the next year. So this first slide here is basically what we, on our planter this year, we did an emergence test. So we went out and flag tested every plant that came up. We flag tested or documented when they came up on every row on the planter. So we've been doing this for a couple of years and trying to correlate our early emergers, late emergers, how that affects yield. And we know there's something to it. We want everything up in the first 36 hours or roughly 12 to 20 GDUs we think is important. So we wanted to see how much variability is there in our planter, because when you go, when you walk across your planter at harvest, you can see there's variation from row to row, and we want to see how much is that and what's causing that. How can we fix that? We've not done this on our field, but I've heard of some guys, hand harvesting row to row and having 150 to 200 bushel difference from one row to the next row. And that, one row might be yielding 350 and another yielding, 200. And can we fix that? We've got a couple different closing systems on our planter. We've got 8 fast track systems, which are basically the case closing system. It's a deer planter. So it's got the, the pinching disc and then a packer wheel. And then we have a couple of precision plantings furrow force system. If you're familiar with that, it's got a weigh pin on it. It measures the amount of down pressure the packer wheel's putting on it. It's kind of somewhat similar to the case system in the fact that it has a set of closing discs and then a packer wheel behind that. This picture is the picture of the flag test. All right, I don't know if you guys have these slides or not, but so this is row 1 through 24 right here. And then this is the cumulative emergence. So in the first 12 hours on row 1, we had 1 plant come up. Row 2, we had 3. Row 3, we had 3. Row 4, we had 0. The colors, if they're red, that means they're the lowest in this column. If they're the green, that's the most. So row 8, we had 10 up on our first check. So there's a good chance we actually had some up. We missed the first spot, potentially. We weren't out there soon enough, possibly. We want everything up right here. And of course, we didn't get everything up right here. The GDU difference, this was planted in May, like May 10th. We thought we had a pretty good forecast. However, I think the total GDU accumulation here is like 25 GDUs. So it's not huge. Sometimes we've seen them take, 50, 60, 70 GDUs between first and last, and that's too much. So what's interesting here, I've got these rows right here show the different closing systems. Here's our furrow force row on row 7, and here's our furrow force row on row 18. What's kind of interesting is they're very similar in emergence. We've got nothing up in 12, 4 up on row 7, 6 up on row 18, and then at the 36-hour emergence, we got quite a few, 13 and 14 up, 27. Our overall emergence on both of those was pretty good, 33 and 32. Pinch rows, here's our pinch rows. You really can't see anything. There's nothing that really jumps out on that. And then over here, row 22 and 22 through 24, I probably should have cut that off. That was, this field's no-till. We usually strip-till, and so we're planting into pretty good seed bed usually. This particular field's no-till. It's our drip field up north, and we haven't put anhydrous on it, so everything's just been broadcast. And our planter had a bit of an issue. I whacked a telephone pole to the field before that, and we've got a custom-made hinge joint that allows a little extra flex. Anyways, it tweaked it back, and so the closing unit was not quite tracking right. And our strip till, it was doing okay, but in the no-till, it was closing it on top, but there was a void in that seed slot. So it's going to be a little interesting. They did come up, but not until it rained. And so it'll be interesting to see how that affects it. Okay, so that's really all there is about the emergence. There's a picture of the flag test. We had about 800 flags in there. So if you're going to do that, make sure you got a lot of flags. All right, so now we're going to talk about boron. We've been trying to figure out how to get boron into our plant for 2 years. Last year, we did a fewe things. It was so wet, we really didn't learn anything. Pretty much we lost whatever we put out, and it was hard to get out with the sprayer to make passes, and we didn't learn a lot. So this year, I'm going to show some of the things we learned. First of all, what does boron do? Well, boron helps development of plant cell cell wall development, helps with root growth, aids in nutrient uptake, especially potassium and also calcium, which calcium's helps also. Well, calcium does a lot of things, but one of the things is it will help plants regulate water usage, makes the plant more efficient with water. And because boron aids with calcium, there's a correlation with better water usage with boron. It's also important in early growth, aids in pollination, flowering. I think Steve talked a little bit about it. Some of those pictures of his ears were filled clear out to the tip, and that's one of the things boron helps with, getting those ears filled clear out. What does a boron deficiency look like? You might see it, this curling on the edge of the leaf, or in the middle to the edge of the leaf, white speckles between the veins. I don't know if you can really see it in that picture. I don't know if there is any. It's going to be more common in lighter soils, sandy soils, high pH, and drought conditions can induce a boron deficiency also. I don't know if I've ever seen a boron deficiency visually in the plants on our farm. We don't have high boron levels in our soil, but I don't know that I've ever seen a deficiency. What is boron toxicity? This is actually from our farm this year. Oh, by the way, if anyone can tell me what's wrong with this plant right here, we got a prize for you or something. Somebody can guess what that is. So we were putting down boron with our planter, 2x2. Last year we did this on, we did probably 4 strips. We just tried it. We have 2x2 on both sides of our planter. And last year we ran 2 pounds of actual boron in our 2x2. And we never even seen it show up in the tissue results. Plants looked great. So this year I was like, okay, well clearly it's not an issue. So we loaded up and went to town. Well, it didn't rain at all from the time we planted to the time this came up. That's what boron toxicity looks like. Basically, roots don't look too good, and that plant I thought was going to die, but that is actually that plant right there. I flagged it and went and dug it up this morning. So it actually didn't die, but it didn't look too good. There's a couple others right down the row from it that don't have an ear on it. It's interesting. This how we seen this was our planter we have conceal on our planter, and there's 4 rows that were beta conceals from 3 years ago. And they were trying different fertilizer placements. So some of them, the knife is putting the boron out at the bottom of the knife. Some of it's coming out the side. Some of it's coming out the back. This one row was coming out the back, and the knife is wore. So the placement of the boron on that row is basically about 1 inch, and it only showed up on that row. On the rest of the row where we had got new conceals and the John Deere fertilizer placement where we're getting it in a full 2 to 2.5 inches deep, it never showed up. But we were a little bit too shallow with that row, it smoked it. How much boron do we need? I'm not totally sure I can answer that question, but it's more than 300 bushel corn calls for 0.8 pounds of boron in just your standard recommendation thing. I can tell you it's more than that. If you want to maintain good levels in your tissue samples, or enough to actually move it, it takes more than 0.8 pounds. Boron is taken into the plant by mass flow, meaning it goes in with the water. So the amount in the soil somewhat correlates with the amount in plant tissue, unlike like phosphorus, which you could actually have a low phosphorus soil value and have high amount in the plant. There's not really any correlation on that. On our farm, our boron soil levels are around 0.8 part per million on average. They range from probably 0.5 to 1.2, but they average around 0.8. And our tissue test levels over the last 5 years have averaged 10 part per million. And we would like to maintain 15 to 20 in our tissue test. By tassel, roughly, we've taken up about 70% of our total boron. If we're going to put it out, we need to be thinking about earlier in the season versus later on. The other lines on that graph are our actual historical average of our boron tests. So all of our tissue tests combined, that's our average trend. That's, I think, on all of the samples in that line are about 240 bushel per acre corn. And then the red line that's straight across, that's our target. That's where we're trying to get to. Now I'm going to show you a couple graphs of the tests that we did this year. Hopefully shed a little light on how do we get boron in the plant. So this field, this is the drip field up north, and basically we said we want to figure out how to maintain above 20 part per million, whatever it takes. So March 10th, we went out there with the dry spreader. We spread 2 pounds an acre of actual Solubor. We were using Solubor. We spread 10 pounds of Solubor, which is 2 pounds of boron. March 10th. Then with the planter, we put on 1 pound in the 2x2. And so that's what this first line right here, this first line, so there's 3 pounds of boron out here before we even plant. The bottom numbers here are GDUs, 350 GDUs, 500. So this is before the planter even gets there, we've got 3 pounds of boron on. The lines here, green line is our waypoint sample, and this orange line is basically the same sample, but it's going to another lab. What we've seen is that there's huge variation in some samples between some nutrient samples in different labs. So that's kind of interesting. And then this other green line is our historical average. We started out the year pretty high, 60 part per million at our waypoint sample, a little lower at seal. And then our levels start falling off. This week, actually all of our waypoint samples came back way low. There was something, I don't know what happened at the lab. We had some came back like 2 and 3 part per million. So I think there's a bit of error here possibly in this, but nonetheless, our levels were coming down. So we went out there with the sprayer, put a pound of boron on, and we were using a Brant 10% liquid product. Got a pretty good response out of that. About 10 days later, we ran 2 pounds of Solubor again through the drip system. And then at Tassel with the airplane, we ran another gallon, which would equate to a pound with the airplane of a Brant 10%. So pretty much most of the year here, we've maintained close to 20 part per million if you're using the waypoint sample, which on all of our samples, this Southeast Ag Labs boron levels have been low. They just, the way it measures it, it's, it's low, which our average sample, that's made up of waypoint samples. So you can see we've definitely raised it here. Now, is this economical? Is this gonna actually work? The Solubor per pound of boron is gonna cost about $7.50 an acre. The Brant is going to run $12.50 an acre for a pound. So we've got 7 pounds of total boron out here. So roughly $70 an acre, $67 an acre, I think. So with corn at $1.50, we need, with 325, I think that'd be like 20 bushel. So I think it's going to be tough to make that pay, but at least we've kind of learned now some things we might try differently. We'll probably skip the broadcast next year, and we'll go 1 pound with the planter and maybe try and come in a little earlier with the sprayer and make, you know, a couple more lower rate foliar passes, I think.
Did you get any big flushing rains? Did that impact your tissue levels, do you think?
Well, in May, mid-May through June, we did have some pretty substantial rains. We had 10 inches in about a 30-day period. We never had any really huge rains this year that I can think of. Last year, everything we did, you know, we had tons of rain last year, 12 inches in a 2-week period, and it never showed up at all. I mean, it was like we didn't even do anything. So it's definitely very leachable. I mean, they say it's one of the most leachable nutrients there is. The Solubor is a dry product that we liquidized. Yeah, liquefied, yep. Yes, correct. Yeah, all this would have been applied as a liquid. Okay, another test we did, this was with the planter. In the 2x2 system, we applied the Solubor and the Brant. We did a side-by-side. So this bottom green line is our control right here. This gold line is the Solubor, and this blue line is the Brant product. According to this, our Brant product got us a pretty good response compared to the Solubor versus our control. This 800 GDUs, that's our sample again, that was clear low. So I wish I would have taken another sample because at the time I didn't know, you know, that was probably, there was potentially something going on there. But you can see about 3 weeks is about what we're gonna get out of it. 3, maybe 4 weeks is about what you're gonna get out of an application. Okay, this is another field we did that we put Solubor in the strip. So we strip tilled this field about March 1st. And we put 2 pounds of Solubor in with our dry fertilizer, put it in the strip, planted right on top of it. And you can see right off, this blue line would be our tissue test. The green line is our historical average again. We're starting lower than our average. We seen this and I was like, well, it's gone already. We didn't see it, which I think could be the case. So we went out at about 600 GDUs and we dry spread with urea Granubor, which is basically supposed to be a slow release boron product. And I was kind of excited about it. Looks like we got about 3 weeks again out of it. But once again, the 3 weeks seems to be about what it is. This is another field with the pivot. We put on 2 pounds of Solubor through the pivot. We solubilized it, ran it through the pivot. This took about 2 weeks for this to show up. Put it on here. Here's 1 week. Here's the second week. And so, 2 to 3 weeks again. It's about what, Same thing as before. I think that's all I got. I think that's the last slide. So any questions? I'll be around for a little bit if anybody's got any questions on anything.